I'm going to do a little review on distance, midpoint, and slope. So go ahead and make a tab, entitle that, and then pause the video and copy all this down. Alright, so let's take a look at distance. First, let me draw the quadrilateral shape, and it doesn't really matter, I just want a rough idea. I want to find the distance around this shape, so I'm going to look at AB first. So I'm going to calculate it from AB. So it says label x1, y1, x2, y2. So I'm going to write down the coordinates for AB, which are 4, 3, and 8, 3. And then I'm going to label it x1, y1. Then x2, y2. Make sure the 1s are with the 1s and the 2s are with the 2s. Write down the formula. So you're going to write down the distance formula, and this is given to you in a reference sheet. So just copy it down from the reference sheet. Alright, plug it in. So we're going to go d equals the square root of x2, which is 8, minus x1, which is 4, squared, plus y2, which is 3, minus y1, which is 3, squared. And then calculate it. Alright, so that's going to be, the distance is the square root of 8 minus 4 is 4, squared, plus 3 minus 3 is 0, squared. And then what's 4 squared? 4 squared is 16, plus 0 squared is 0. And then so 16 plus 0 is 16, so square root of 16 is 4. That's how you do it with our calculator. But thankfully you have a calculator, so from now on I'll show you how to do that. Next length is going to be from B to C, so I need the coordinates for B and C. So B is 8, 3, and C is 9, 10. First thing you do is label x1, y1, x2, y2. And then we already wrote down the formula, so I'm just going to plug it in because I know the formula. x2, which is 4, minus x1, which is 8, squared, plus y2, which is 10, minus y1, which is 3, squared. Alright, then calculate it. Alright, so all you got to do is put in the calculator exactly how it looks. So square root, open parenthesis, 9 minus 8, close parenthesis, squared button, plus, open parenthesis, 10 minus 3, close parenthesis, squared button. And then press enter. And make sure it matches exactly that. So that's going to be 7.1. This is a listening check, shade in the quadrilateral. Just finding all the sides around this quadrilateral. And by the way, the quadrilateral doesn't necessarily look like that. So write down the coordinates for C and D, label x1, y1, x2, y2, and then plug it in the formula. So the square root of x2, which is 5, minus x1, which is 9, squared, plus y2, which is 10, minus y1, which is 10, squared. Take a calculator, copy it down exactly how it is. So 5 minus 9 squared, plus parentheses, 10 minus 10, close parentheses, squared. That's going to be 4. So always make sure what's on your calculator is what's on your paper. Alright, last one, going back up, DA. So I need the coordinates for D and A, and I ran out of space, so I'm going to squeeze it over here. So write down the coordinate for D and A. Alright, again, label x1, y1, x2, y2, and you're plugging it in. So x2 is 4, so parenthesis 4 minus x1, which is 5, squared, plus, open parenthesis, 3 minus y2, which is 10, squared. And then punch that all in the calculator just like you see it. Make sure it matches. Press enter. 7.1. Alright, so just with distance, it's very easy. It's just plug it in the formula and you have the formula in the reference sheet. Now I've gone ahead and highlighted the answers because you can see that two sides are the same and then the other two sides are the same. And I'll come back to why this is important a little bit later. Alright, midpoint. Midpoint is the same kind of thing. It's really easy. It's finding the middle. So to find the midpoint, I want to draw the diagonals. So I'm looking for AC and AD. AC and AD. AC and AD. So I need the coordinates for A and C. So I'm going to write those down because it says label x1, y1, x2, y2. And then I'm going to go ahead and label them. And then it says sing the song. So there's this song that says, midpoint, midpoint, what do you do? Add them together and divide by 2. Midpoint, midpoint, what do you do? Add them together and divide by 2. Midpoint, midpoint, what do you do? Add them together and divide by 2. Hey, midpoint, midpoint, what do you do? Add them together and divide by 2. Hey! Alright, so we're all singing that in class, by the way. Alright, then once you do that, it's very easy. You just add in the x's and divide them by 2, and add in the y's and divide it by 2. Once you've done that, you just simplify it. So 4 plus 9 is 13 over 2. And then the y coordinate is 3 plus 10 is 13 over 2. And you punch out in the calculator, you're going to get 6.5 for both. Alright, the other midpoint I'm looking for is, I found AC, so I'm now looking for a BD or DB, because I'm finding the midpoint of the diagonals. This is a listening check, put a star by BD. So label x1, y1, sing the song. Midpoint, midpoint, what do? Add them together and divide by 2. Alright, so you're adding the x's together, so 8 plus 5, divided by 2. You're adding the y's together, so 3 plus 10, and dividing that by 2. 8 plus 5 is 13, divided by 2. 3 plus 10 is 13, divided by 2, so it's going to give me 6.5, 6.5. So you can see that they're the same. The x and the y coordinate are the same. And we'll get into that in a little bit. Alright, so now I'm going to look at slope. I'm going to look at the slopes of the side. So I'm going to look at AD. And there are these steps that you can do, or you can do the second one. I'm going to do the second one because that's what I'm used to. So I'm going to draw one arrow from one x to the other. And then ask myself, how did I change? How did I get from 4 to 5? I added 1. So 4 plus 1 is 5. Alright, do the same thing from y. You have to start at the same place you started. So how do I get from 3 to 10? I'm going to add 7. 3 plus 7 is 10. Then you're going to do change in y, which is plus 7, over change in x, which is plus 1. And then the final step is to simplify. Positive 7 divided by positive 1 is positive 7. And you're going to do the same thing for all the slopes. So that's the slope AD. I'm going to look at the slope BC, parallel to it. I want to see if they're parallel, basically. So write down the coordinates for B and C. And again, you can do the very first section, label x1, y1, etc. and plug it in, but I don't do it that way. Alright, so again, change in y over change in x. So from 3 to 10, how did I get there? Added 7. From 8 to 9, I added 1. Change in y over change in x, so plus 7, that's a change in y, over change in x, which is plus 1, giving me 7. So you can see AD and BC have the same slope. I'm going to talk to you about why that's important. Now I'm going to check the horizontal ones, or what I think is horizontal. AB, change in y, 3 to 3 plus 0. 4 to 8, what did I do? I added 4. Change in y is 0 over change in x plus 4, which is 0. And check DC, the bottom. So write down the coordinates for DC. And then I do change in y over change in x. Now I'm always starting from the left in all of these examples, but I want to show you that you can really start from the right. You're going to get the same exact thing. So change in y, 10 to 10, I'm going to add 0. And then 9 to 5, I'm going to subtract 4. So 9 minus 4 is 5. So that's change in y over change in x, and it still gives me 0. Alright, so the question was, what kind of quadrilateral is this? So I'm just going to sketch a quadrilateral, label it A, B, C, D. And I don't know what it is. I've drawn it like this, but I don't know what it is. But I'm going to put in the information that I found. So we know AB is congruent to CD because they're both 4. And then we know that BC is congruent to AD because they're both 7.1. And we're going to use 2 ticks because they're different numbers. Alright, what else do we know? Midpoint. Alright, so let's draw the diagonal AC. And we know that the middle is the coordinate 6.5, 6.5. So if I draw like a rough sketch of a coordinate grid, 6.5x and 6.5y would be this middle point. And then also for the diagonal BD, the midpoint is at the same place. So what can we say about that? The diagonals bisect each other, which means that this little piece, 3 ticks, is equal to that little piece. And then this little piece, 4 ticks, is equal to that little part, 4 ticks. They're not the same because we don't know if the lengths are the same. Alright, then we're going to look at slope. When you have slope that's the same, the lines are parallel. So same slope, the lines are parallel. If you have slopes that are flipped and the sign is changed, then they're perpendicular. This is a listening check. Color in these 2 lines that I've written in red. Okay, so we see we have the same slope. So those 2 are the same slope. So what does that mean? That's parallel. So AB is parallel to BC. Then these 2 have the same slope of 0. So that AB is parallel to CD. Okay. What else do we know? Okay. So this is a parallelogram, but we need to see if it's anything else. Like, is it a rhombus, a rectangle, or a square? Again, I just drew it, so you can't go off this picture because I just drew it. So I'm going to check the slope of AC and BD to see if that slope is going to meet at 90, because if diagonals are 90 in the middle, I know that it is a rhombus or a square. So I'm checking the slope, changing y over changing x. So for the slope of AC, 7/5, and I'm going to check the slope of BD. So write down the coordinates. Changing y is going to go from 3 to 10, which is plus 7, and then start in the same place from 8 to 5, which is -3. Changing y is plus 7 over changing x is -3, which simplifies -7/3. Now the sign has changed, but they haven't flipped because it's supposed to be 5/7. So it's not perpendicular. So we know that this is not a rhombus and definitely not a square. So now we're going to check if it's a rectangle. So let me remind you of the family tree again. Parallelogram gives birth to a rhombus, which is slanted square, and also gives birth to a rectangle, who give birth to a square. So we know it's not a rhombus because the diagonals don't meet at 90, because the slopes of the diagonals are not perpendicular. So now I'm going to check to see if it's a rectangle and see if the corner angles are 90. So that means I need to check the slope of AD and AB. If that's 90, then it could be a rectangle. So I think I've already worked this one out actually. So the slope of AD is 7, the slope of AB is 0. Are those perpendicular? Meaning if you flip it and change the signs, you get the same number? No. So it's not a rectangle either. So it has to be a parallelogram. And we're going to practice more of these, but I just wanted to give you a quick review on distance, midpoint, and slope, because it's what you need in order to prove quadrilaterals in the coordinate plane, which is our next video. As a listening check, put a box around the word parallelogram. Let's practice.